codes for bonding and grounding CATV for residential and commercial buildings are not the same. For residential CATV bonding and grounding, one must comply with Article 820 of the National Electrical Code, NEC, which covers antenna installations. For commercial CATV bonding and grounding, one must reference Articles 810 and 820 of NFPA 70, which is the National Electrical Code, NEC, as well as NFPA 780 standard for the installation of lightning protection systems and ANSI/TI 568. C1. Commercial Building Telecommunications Cabling Standard. The main differences between bonding and grounding requirements for residential and commercial CATV installations include the grounding electrode system, GES. Commercial buildings typically have a more complex GES than residential buildings. In commercial buildings, it is not always possible to bond to water pipes due to the use of plastic or dissimilar metal piping. Commercial installations may require additional ground rods to achieve a low-resistance path to ground. Commercial buildings are more likely to require lightning protection, which involves additional bonding and grounding requirements. Commercial CATV installations may require more detailed documentation, such as bonding and grounding diagrams. General bonding and grounding principles dictate that all metal components of the CATV system must be bonded together. The bonding system must be connected to the building's GES. The GES must have a low resistance path to ground. All coaxial cables must be grounded at both ends, and all external equipment, for example amplifiers and splitters, must be bonded to the grounding system. The National Electrical Code, NEC, provides comprehensive guidelines for grounding and bonding electrical systems, including CATV systems. Grounding ensures a low impedance path for fault currents, minimizing the risk of electrical shock and equipment damage. Bonding connects metallic parts to create an electrically conductive path, reducing voltage differences and providing a path for fault currents. Article 820 specifically addresses the grounding and bonding requirements for CATV systems. It outlines the methods for grounding the coaxial cable shield, the equipment, and the grounding electrode system. The grounding electrode system typically includes a ground rod, metal water pipe, or other approved grounding electrodes. Proper grounding and bonding are essential for the safe and reliable operation of CATV systems. In residential installations, the CATV system is typically grounded to the building's grounding electrode system. This can be achieved by connecting the coaxial cable shield to a ground rod or metal water pipe. The grounding conductor must be sized appropriately and installed in accordance with the NEC requirement. All metallic parts of the CATV system, such as amplifiers and splitters, must be bonded together to create an equipotential plane. This reduces the risk of voltage differences and provides a path for fault currents to flow back to the source. In commercial installations, the grounding and bonding requirements are more stringent due to the larger size and complexity of the systems. Commercial buildings often have multiple grounding electrodes and a more extensive bonding network. The CATV system must be grounded to the building's grounding electrode system, which may include ground rods, metal water pipes, and structural steel. The grounding conductor must be sized appropriately and installed in accordance with the NEC requirements. All metallic parts of the CATV system must be bonded together to create an equipotential plane. This includes the coaxial cable shields, equipment enclosures, and any other metallic components. The bonding network must be designed to provide a low impedance path for fault currents, minimizing the risk of electrical shock and equipment damage. In addition to the NEC requirements, some commercial installations may also be subject to other codes and standards, such as the NFPA 780 standard for the installation of lightning protection systems. These standards provide additional guidance on grounding and bonding for lightning protection. It is important to consult with a qualified electrician or engineer to ensure that the CATV system is properly grounded and bonded in accordance with all applicable codes and standards. Improper grounding and bonding can create a serious safety hazard and can also affect the performance of the CATV system. The grounding electrode system, or GES, is a critical component of the electrical safety system. It provides a low impedance path for fault currents to flow back to the source, minimizing the risk of electrical shock and equipment damage. The GES typically consists of one or more grounding electrodes, such as ground rods, metal water pipes, or structural steel. The grounding electrodes must be installed in accordance with the NEC requirements and must be properly connected to the electrical system. The grounding conductor is the conductor that connects the electrical system to the grounding electrode system. The grounding conductor must be sized appropriately for the size of the electrical system and must be installed in accordance with the NEC requirements. Bonding is the process of connecting metallic parts together to create an electrically conductive path. Bonding reduces voltage differences and provides a path for fault currents to flow back to the source. All metallic parts of the electrical system, such as equipment enclosures, conduit, and piping, must be bonded together. The bonding conductors must be sized appropriately and installed in accordance with the NEC requirements. Lightning protection systems are designed to protect buildings and equipment from the damaging effects of lightning strikes. Lightning protection systems typically consist of air terminals, down conductors, and a grounding electrode system. The air terminals are installed on the roof of the building and are designed to intercept lightning strikes. The down conductors carry the lightning current from the air terminals to the grounding electrode system. The grounding electrode system dissipates the lightning current into the earth. Proper grounding and bonding are essential for the effective operation of lightning protection systems. The grounding electrode system must be designed to provide a low impedance path for lightning currents to flow into the earth. The bonding conductors must be sized appropriately and installed in accordance with the NEC requirements. It is important to consult with a qualified lightning protection specialist to ensure that the lightning protection system is properly designed and installed. The ANSI/TIAMNS 568 C1 standard provides guidelines for the design and installation of telecommunications cabling systems in commercial buildings. This standard covers a wide range of topics including cabling types, cabling pathways, and cabling termination. The standard also includes requirements for grounding and bonding telecommunications cabling systems. The grounding and bonding requirements in ANSI/TIAMNS 568 C1 are similar to those in the NEC. The standard requires that all metallic parts of the telecommunications cabling system be bonded together to create an electrically conductive path. The bonding conductors must be sized appropriately and installed in accordance with the standard. The telecommunications cabling system must also be grounded to the building's grounding electrode system. The grounding conductor must be sized appropriately and installed in accordance with the standard. Proper grounding and bonding of telecommunications cabling systems is essential for the safe and reliable operation of the systems. Improper grounding and bonding can create a serious safety hazard and can also affect the performance of the systems. The NEC, specifically Article 820, addresses community antenna television, CATV, and radio distribution systems. It covers the installation of coaxial cable and associated equipment for receiving and distributing television and radio signals. The article provides requirements for grounding, bonding, and protection from overvoltage. Section 820.93 covers grounding of the coaxial cable shield. It requires that the cable shield be grounded as close as practicable to the point of entrance to the building. The grounding conductor must be connected to the building's grounding electrode system. Section 820.100 covers bonding of the coaxial cable system. It requires that all metallic parts of the system, such as equipment enclosures, conduit, and piping, be bonded together. The bonding conductors must be sized appropriately and installed in accordance with the NEC requirements. Section 820.110 covers protection from overvoltage. It requires that the coaxial cable system be protected from overvoltage by a listed primary protector. The primary protector must be installed in accordance with the NEC requirements. The primary protector must be connected to the building's grounding electrode system. The NEC is a comprehensive set of standards for electrical safety. It is updated every 3 years and is adopted by most states and local jurisdictions in the United States. The NEC provides detailed requirements for grounding, bonding, and overcurrent protection. It is essential for electricians and electrical contractors to be familiar with NEC requirements in order to ensure the safe and reliable installation of electrical systems. The NFPA 17 National Electrical Code is the most widely adopted electrical code in the United States. It provides requirements for the safe installation of electrical wiring and equipment. The NEC is developed and published by the National Fire Protection Association, NFPA. The NEC is updated every 3 years and is adopted by most states and local jurisdictions in the United States. The NEC is a comprehensive set of standards for electrical safety. It is essential for electricians and electrical contractors to be familiar with the NEC requirements in order to ensure the safe and reliable installation of electrical systems. The NFPA 780 standard for the installation of lightning protection systems provides requirements for the design, installation, and maintenance of lightning protection systems. The standard covers a wide range of topics, including air terminals, down conductors, grounding electrode systems, and surge protection. The NFPA 780 is developed and published by the National Fire Protection Association, NFPA. The standard is updated every 3 years and is adopted by many states and local jurisdictions in the United States. NFPA 780 is a comprehensive set of standards for lightning protection. It is essential for lightning protection specialists to be familiar with the NFPA 780 requirements in order to ensure the effective protection of buildings and equipment from lightning strikes. The ANSI/GI 568 series of standards specifies cabling systems for commercial buildings. It addresses aspects like performance requirements, cabling types, and installation practices. These standards ensure interoperability and consistent performance across different manufacturers' products. It's important to note that electrical codes and standards are constantly evolving. Always refer to the latest edition of the NEC and other relevant standards for the most up-to-date requirements. Also, local jurisdictions may have additional requirements that must be followed. Consult with local authorities to ensure compliance with all applicable codes and regulations. When dealing with electrical systems, safety is paramount. Always de-energize circuits before working on them and use appropriate personal protective equipment, PPE, such as insulated gloves and safety glasses. If you are not a qualified electrician, do not attempt to perform electrical work. Contact a qualified electrician to perform any electrical work that you are not comfortable with. Understanding the specific requirements for residential and commercial CATV systems is crucial for ensuring both safety and optimal performance. While the general principles of grounding and bonding remain the same, the complexity and scale of commercial installations necessitate more robust and comprehensive measures. Paying close attention to the relevant articles in the NEC and other applicable standards will help to ensure that CATV systems are installed safely and in compliance with all applicable codes and regulations. Always remember to consult with qualified professionals for any electrical work to guarantee a safe and effective installation.